All right, now we're going to talk about the least squares regression line. So, the least squares regression line, also known as the line of best fit. So, you may have heard the least squares regression line. That might not make too much sense or familiarity, but you may have heard the line of best fit. That's all this is. So, this is going to get a little more wordy than we need to really worry about for this class, but just for the future stuff, in case anybody is curious, what this does is it minimizes the sum of the squared errors, also known as the residuals. So this line minimizes the sum of the squared vertical distance between the observed values of y and those predicted in the line. And the line is y with a hat over it, which we've seen p hat before, so this is just called y hat. So basically, we don't necessarily need to know about this unless you're not watching this video and you're going to try to figure it out on your own. If you don't use the calculator, then you'll have to figure this out, and this super sucks. So luckily you're watching this, though, and you won't be using your calculator, and you won't have to worry about learning it on your own. But any case, so basically what happens is if you have a bunch of points on a line, right? So these are the observed points that we have in our scatter plot. And basically what this says is that if we're trying to make a line that best works for it, right, the distance from here to the line should be minimized. So it's the smallest difference, as it were, right, depending on the way you make it. And again, we don't need to necessarily worry too much about how our calculator is going to make the line, because the calculator is going to do it. We just need to know the so what of it once our calculator gives it to us. So, speaking of, what is our calculator going to give us? Our calculator is going to give us this equation. Y hat equals A plus BX. So, this may look familiar, right? It's very similar to MX plus B, right? Again, the only letters that super matter are the Y and the X. So, basically, it's something X plus something, right? You may also see this in other ways. It might say B0 plus B1. You may also see this as well. All of these mean the same thing, right? It's something plus something X, right? Something X plus something. That's all that matters. But this is what we'll see in our calculator. Our calculators will give us this. And we're going to see that B, the thing next to the X, is our slope. It's the slope of the line. And A is the y-intercept. So the thing next to X is going to be the slope. That's B. The thing by itself is going to be called the y-intercept. So, slope. Oh. All right. Hopefully, this will stick. Good. All right. Let's talk about slope. So, quick refresher. Slope, remember, it just measures its steepness, right? So, the steepness of the line. Typically, we write it as rise over run. So, rise, right? If you're rising, you're going up or down. So basically, these are the y values, right? So it's the change in your y values over run. Run is typically, if you're running, you're going front to back. And this is the x values. So over the change in your x values. So here's an example. If we say that a slope has a line, man, that is just going to be annoying. That's fine. If the slope has a, so if we have a slope of 2/3, for instance, right? Then we would say as x increases by, now remember, it's y over x. So x is going to increase by 3. We would say that y would also increase, because it's positive, by 2, right? As x increases by 3, which is the bottom number, y will also increase by 2. We can also see if the slope is -4, then if x increases by, well, hold on a second, this isn't supposed to be a value over a value, right? Rise over run. Well, if you remember, hopefully, and if not, that's fine, I'm going to tell you, right? You can turn any number into a fraction by just putting it over what? You can put it over 1, right? Because you can plug into your calculator if you don't believe me, but if you divide any number by 1, you just get that number, right? So we can just divide the -4 by 1. So now as x increases by, remember, over x, right? Y over x. As x increases by 1, y will... So notice it's -4, so it's not going to increase. It will decrease by 4. All right, and we'll look at more examples. Obviously, you can see the word problems. It already asks you how to interpret the slope. So we'll definitely talk more about that as we go. Y-intercept. So the y-intercept is the place where the graph intersects the vertical line. So in general, another way to say this, so we have two different ways of interpreting it. So interpretation is that the y value we interpret a y-intercept as being the value of which variable? So if it's the y-intercept, which one's y? Which variable is the y one? The y value is the response variable when the value of the explanatory variable is 0, right? Because if it's when it crosses the vertical line, right, the vertical axis, as it were, then what do we know about the x value? Well, x is just 0 at all these points, right? So another way to say that is the y-intercept is the value of y when x is 0. So when we are talking about the y-intercept, two things to ask ourselves. Does the x make sense? Does it make sense that 0 could be a value for the explanatory variable? Does it make sense that x could be 0? And then once we find, and then if that's yes, then do any of the observations, remember the y values, do any observations near x equals 0 exist? Does it also make sense for us to even have any observations near x equals 0? And we'll talk about that as well. All right, so let's look at problem number 1 in our word problems. So because cola tends to be healthier, oh, okay, so we've already looked at this one, right? So we looked at this in the video 4.1. So if you haven't watched that, go back and watch video 4.1. We'll definitely need that for this section. But let's find the least squares regression line when we treat colas as the explanatory variable. So colas is L1, bone density is L2, and funny enough, when we try to find the least regression line, the least squares regression line, we're going to use lin-reg t-test, right? Linear regression. That's what lin-reg means. Regression line. Good. What's the only thing we need to make sure in lin-reg t-test? We need to make sure that rho does not equal 0. So after you plug all this into L1 and L2, and we go to lin-reg t-test, so again, if you need to pause this video, totally okay. So you'll see at the top of your calculator, you'll see y equals a plus bx, right? So you just need to tell me, or y equals a plus bx. So you'll just need to tell me what are the values. So a is 0.883, and b is negative 0.00234. Ish, right? But I don't want just this. You need the whole thing, right? This is just a number, and this is another number, right? So if you put this minus that, that doesn't tell me anything, right? So we need the whole thing. So it's y hat, excuse me, equals this value plus this x. You need the whole thing. You need the y bar or the y hat. You need the equals, the plus, and the x. So this is our answer, and this is a perfectly acceptable answer. Another answer that you could say is y hat equals 0.883 minus 0.00234x. Because if you're adding a negative, that's the same as subtracting. But if you don't want that, if you just want to put the plus negative, that's totally okay too. But remember, you need everything, all of it. So let's interpret the slope. So part B is going to be interpret the slope. So first, what is the slope? Is it A or is it B? It's B, right? So this is our slope. So let's interpret it. So for every unit increase in, so if we notice, right, if we go back to the original, this was the X value. So what's the X value? X is your L1, so in colas. So every increase in the number of colas consumed now we have the Y value, so the bone mineral density will blank by how many units? So this will either increase or decrease. So we see that our B is negative 0.00234. So since it's negative, it's going to decrease by 0.00234. All right. Now we have the y-intercept. So our A is our y-intercept. So for 0, remember which one is 0? Is it y or x? So for a y-intercept, x is equal to 0. So for 0 number of colas consumed, because remember that's what we said the explanatory variable was. Now we write our y value. The bone density, the bone mineral density is predicted to be 0.883, right? Because that's what we said A was, 0.883. Now, we ask ourselves, does this make sense? Does it make sense to drink 0 number of colas? Yeah. You could not drink soda. That makes sense. Would it make sense that our bone density score could be around 0.883? Well, if we look at all the other values, yeah. I mean, they're pretty close to 0.883. This actual value was 0.882. So, yeah, it would make sense. So, good. All right. So, let's skip part D and E, and let's move on to problem number 2 for now. So here we go with these cricket chirps and the temperature again. So let's find the least squares regression line treating temperature as the explanatory variable. So again, L1 is going to be temperature, L2 is the cricket chirps. So when you plug all this stuff into your calculator, then we're going to go to linreg t-test. So what's the only thing we need to check in linreg t-test? Make sure that rho does not equal to 0. That's true. Good. So, again, if you need to pause this video, go for it. So when we get the whole thing, right, what's our least squares regression line? So the whole thing. So it's y hat equals negative 162.92 plus 14.60x. And if you have more decimals than I do, that's totally okay. You basically, if it asks you to put a number, do that one. And if not, you can put however many you need. But definitely make sure that you have at least something, right? So over here in that first example, don't just put 0x, put some value, right? 0.002 at the very least. All right, so there is our least squares regression line. So we can see that the slope is going to be what? So slope is 14.6, which means that as we increase our x value, what did we say x was? As we increase a unit in temperature, the y value, the number of cricket chirps per minute, Does it increase or decrease? It's positive, so it increases by about 15. All right, you can write 14.6, that's totally fine too, but if we're talking about a number, right, that would just be about 15. All right, let's look at the y-intercept. So the y-intercept we said was negative 162.92, which means that for 0 temperature, right, or we could say for 0 degrees Fahrenheit, for 0 temperature, the number of chirps per minute, this is the y value, is predicted to be negative 163. So again, you can put that, but the approximation is negative 163. So does this make sense? No. Right? This doesn't make any sense. You can't have a negative number of cricket chirps. You either have 0 or positive. You can't have a negative one, right? Which is okay. It's okay that our y-intercept doesn't make any sense. It's just good to know. So we can only go so far. We can't go so far as 0 degrees Fahrenheit. We need to keep it within our range. If we see what our range was for temperature, it was between 69.7 and 93.3, right? 0 is too far away from that data, so you can't predict the further it gets away. All right, let's do problem number 3. So again, skipping D and E. So problem 3 was talking about the enrollment and the burglaries. So let's make enrollment the explanatory variable. L1 is enrollment, L2 is burglaries. So putting those into our calculator. And I would suggest actually going through this process, right? Pausing the video, typing everything to the calculator. The more repetition you have, the better. That's why I do multiple problems for these videos. It's not just so you can watch me do it, it's so you can do it with me. So if you need to pause the video, I would definitely suggest doing that. The only thing we need in reg t-test is making sure that rho does not equal to 0. That's true. So after we hit enter, we see that our least squares regression line is going to be negative 63.77 plus 3.467x, the whole thing. So looking at slope, we said slope was 1.467, right? It's the thing next to the x. So for every value that x increases, we said x was enrollment. So when we increase in enrollment, then the y value, which we said was the number of burglaries, right? Because x is your explanatory variable, that's enrollment. Y is your response variable, which are burglaries. Well, this is positive, so increase or decrease. It increases by about 3. So we can say 3.467. It's fine. It'll either tell you to round or it won't. All right. Y value. So we see that, or sorry, y-intercept. You see the y-intercept was negative 60 or negative 36.77. So for 0, we could say for 0 students enrolled, right? Because this would be x equals 0. The number of burglaries is predicted to be negative 67, right? Or negative, sorry, 36, 37. So you could say negative 36.772. And of course, does this make any sense? No, it does not. No sense at all. You can't have a negative number of burglaries, right? All right. Now that we've gotten those under our belt, let's actually talk about using the regression line for predictions. So when making predictions, the first thing we need to know is is there a linear correlation? If there is, then we use the least regression line, right? If it's linear correlation, we use the regression line. And we do that by just plugging in your x value into the equation. If it's not linear, then you can't use the line. So instead, we need to do something else. Okay, so first, notice. So let's go, if we go to part D for all of these problems that I've done so far, right? Notice it just says predict, blah, 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 blah. So where does it ask you to do linear correlation? It doesn't. It never asks you that. So that is now a super secret question. And it's not a super secret question because I made a super secret question. It's a super secret question because it just is, right? The homework is not going to ask you this question. It's not going to ask you, hey, is it linear correlation? Then you need to then do this or that, right? You have to know to look for linear correlation. And I'm such a great professor that I'm letting you know what the super secret question is. So this is an easy one to forget because most people, when it says predict, they automatically just say, oh, I'm just going to plug it in. But that's only half of the time, right? If it's not linear, you can't plug it in. So a good thing to guess. So basically what happens if it isn't linear and you have to guess something? Well, a good thing to guess is probably the mean, right? The average. So we're going to take the sample mean of what? So basically, it's trying to give you an x value to predict a y value, right? So we want to predict the y value. So since we want to predict the y value, we need to find the mean of the y values, not the x values. So here we go. So if it is linear, we use the regression line. If not, we use the mean of the y values. And the reason why we put y bar, right, is because x bar was the sample mean for the x values. So y bar is the sample mean for the y values. All right, and we're just going to have to get rid of this. Oop. There we go. All right. So let's look at problem number 4. So which way are we going to use probably when we're trying to make predictions? So we can see this goes up and this regression line looks pretty good. So we are probably using the least squares regression line, right? The line pretty much goes with the data, so we have to prove it, but we'll probably use the linear regression line because it's probably linear. What about this one? So we can see the data is all over the place and it doesn't really go in this method, right? So we can't use the linear regression or the regression line. So instead we're going to use the sample mean of the y values. Okay, so let's go back to problem number 4. So part D. Oh, sorry, problem number 3, excuse me. Part D. So this is what we determined was our linear regression. So predict the number of burglaries where 25,000 students enrolled. So we're just going to plug this into our x value, right? Hopefully you said no, or you thought no, right? Because the super secret question we ask ourselves is what? Is there a linear correlation? And the way to find that, how do you find that? So remember that was the second part. So we would have to look at the p-value, right? So hopefully we already have all this data in our calculator. So going back to linreg t-test, Making sure that rho does not equal to 0. We can see that the p-value was 0.0914, and the significance level was 0.05. Since it's bigger, we failed to reject, right? So there is no linear correlation, right? There wasn't enough evidence to conclude linear correlation. So can we use this line? No, we cannot. So then how do we figure it out? We got to use the sample mean of the y values, right? So what we're going to do is we're just going to add up all these numbers and then divide by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Divide by 10. So add them all up, divide by 10. And when we do that, we see that we get about 87.7 burglaries. So if there's 25,000 students enrolled, we would expect about 87.7 burglaries. Let's do part E. What about if there's 50,000 enrolled students? Well, again, what's the super secret question? You can't just plug this in. You got to ask yourself, is it a linear correlation? Well, we already showed that. We said it wasn't, right? No, it's not. So if it's not, what do we have to use? We have to use the sample mean. And we said the sample mean was 87.7. So it's the same answer. Right? Yeah, which ends up being great because whatever they ask us to predict, if we know the answer is no, we don't got to do anything. We just say sample mean, 87.7 for all of them. All right, let's go back and do problem number 2, part D and E. So remember we said that the temperature was L1, the number of cricket chirps was L2. So you'll need to go back and plug all that back into your calculator. And why do you need to do that? Why would you need to do that? Because we're trying to predict. What do we have to ask ourselves? What's the super secret question? Predict. We have to ask ourselves, is it a linear correlation? So looking at our p-value, which is we find with the Lin-Reg t-test, right? We see that the p-value is 0.0046. The significance level was never given, so that's just 0.05. It's less, so we reject the null hypothesis. So there is sufficient evidence for linear correlation. There is a linear correlation. All right. So since the answer is yes, how do we predict with 70 degrees Fahrenheit? So we just plug it in. So we see that the y value is going to be negative 162.92 plus 14.60 times 70. And again, if you have different number of decimals, yours is going to be a little different than mine, but it should be about all the same. So we get about 859 chirps per minute. Part D. Let's predict the number of chirps if it's 85 degrees Fahrenheit. So predicting, we need to ask ourselves the super secret question, is there a linear correlation? We already answered that. Yes, there was. So we just plug it in. So y hat is negative 162.92 plus 14.60 times 85. And we get about 1,078 chirps per minute. Problem 1. So we said that the COLA was list 1, the bone density was list 2. So predicting the bone density, what's the first thing we gotta ask ourselves? Is there a linear correlation? right? After you plug this in and do linreg t-test again, you'll see that the p-value is 0.0174. Significance level, as always for these problems, are 0.05. So it's less, which means that we reject. So there is sufficient evidence to conclude a linear correlation. There is a linear correlation. So since there is, we just plug it in. So we say that y hat is 0.883 minus 0.00234 times 6, which is about 0.869. So that's the bone mineral density at 6 cans of cola per week. What about 9 cans of cola per week? Well, again, is there a linear correlation? Yeah, we already showed that, right? So then we just plug this into the equation, plug 9 into the equation. Y hat is 0.883 minus 0.00234 times 9, which is 0.862. All right, 2 more problems, and then we'll call it a day. We'll just start from the beginning, right? Do the whole thing. So problem number 5, this was the PSAT and the SAT questions that we talked about. So let's let the PSAT be the explanatory variable. So L1 is the PSAT. The SAT will be L2. So find the least regression line. So after you plug all that in, we're going to go to linreg t-test. We just need to make sure that rho does not equal to 0. It's true. So then our linear regression is y hat equals 1313.72 plus 4.562x. So the slope, 4.562. So as the x value increases, we said the x was the PSAT score. So as the PSAT score increases, the SAT score, this is positive, so increase or decrease. It also increases by 4.562. The y-intercept we said was 1313.72. So for, remember, y-intercept is when x is 0. So for a 0 PSAT score, the SAT score is predicted to be about 1313.72. Now, does this make sense? Well, if we go back to the beginning of our problem, so we didn't actually read this out loud, so I probably should have, so I apologize. So it says, recall that PSAT scores can only be between 130 and 220. So can you have a PSAT score that's 0? No, you cannot. So, once again, this x-intercept makes no sense because you cannot have a PSAT score that's equal to 0. All right, prediction. When's the SAT score the same as the PS, or what is the SAT score when the PSAT score is 140? So we're going to plug 140 into our equation and then call it a day, right? Hopefully you said no. And why? Why would you have said no? What's our super secret question? Is there a linear correlation? So in our calculators, you already have linreg t-test, right? So you can go back to it real quick. What's our p-value? So for this one, our p-value is 0.1640. Alpha is 0.05. So the p-value is bigger, which means that we fail to reject our assumption. So there is not sufficient evidence for a linear correlation. So it's not a linear correlation. So linear correlation? Nope. So good. I'm glad we didn't plug it in because then we're not supposed to, right? So what are you supposed to do now? We have to find the mean of the y values. So you got to add all these up, all these SAT score values up, and then divide by 1, 2, 3, 4, 5, 6, 7, 8. There's 8 of them. Yeah, sum divided by 8. And when you find that, you see that the sample mean is equal to 2152.5. So if the PSAT score is 140, then the SAT score will be about 2152. All right, what about if the PSAT score is 210? Well, now we'll plug it in, right? No. We have to ask ourselves again, is there a linear correlation? We actually already showed there wasn't, right? From part D. So if it wasn't then, it's not now. So we still can't use the sample, or we still can't plug it in. So we would just use the sample mean again, which we already found. Right? 2152.5. Good. That's it. All right, last problem. So here's our altitude and temperature one again. So let's let altitude be the explanatory variable. So L1, L2. So when we plug all those in, we're going to find our regression line. We need to do len reg t-test. Make sure rho does not equal to 0. Now len reg t-test will be, the regression line will be 72.498 plus negative 3.684x. Right? Or we could do it just subtracting. Right? Either of these. Remember, there always will be a line of best fit. There will always be a best fit line. Doesn't mean it's a good fit. That's why we have to check, is it linear? Are we going to use it? Is it a linear correlation? All right, so slope, we said slope was negative 3.684. So when the x value increases, what do we say x was? X was the altitude. So as we increase in the altitude, the temperature, all right, we see the value is negative. So is it increase or decrease? It decreases by 3.684. All right, y-intercept. We said that was 72.498. So for 0 altitude, right, we said altitude was in thousands of feet. So for 0 feet, there we go, for 0 feet, essentially above sea level, right? For 0 feet, the temperature is predicted to be 72.498 degrees Fahrenheit. Does this make sense? Well, it doesn't say that our altitude can't be 0, so that's good. And can a temperature be 72 degrees Fahrenheit? Yeah, absolutely. So actually, this one does make sense. Woo! We finally got one that makes sense. All right, let's do predictions. So predict the temperature when the altitude is 15,000. So hopefully we ask ourselves our super secret question, which is there a linear correlation? So to figure that out, right, we go into our len reg t-test and we look at our p-value. P-value is, can it be bigger than 1? No. So you got to look at that e value. So when you move that decimal, we just see it's 0, right? Then we get alpha, which is 0.05. It's less than, so we reject the assumption. So there is sufficient evidence to conclude that it is a linear correlation. So is it a correlation? Yes. Yes, it is. So we can plug this in. So here's my question. Are we going to plug in 15,000? Because that's what it says, right? 15,000 feet. So we just plug in 15,000, right? So no. Why? What does it say altitude is in? What units is the altitude? It's in thousands of feet. So if you wrote 15,000 into our altitude, that's 15,000, which is 15 million. We are not 15 million feet above sea level, right? So we're not going to do 15,000. What are we just going to write? It'll just be 15, right? Because it's already in thousands. So we're just going to write 15 for this problem. And when we do that, we see that we are at 17.2 degrees Fahrenheit. All right, what if we are at 32,000 feet? Again, you ask yourself, is it a linear correlation? Yes, it is, right? And again, it might just seem tedious. You've already decided this, but going through the process, right, asking yourself every single time, that's going to be helpful. So it is, so since it is, we plug it in, and since it's already in thousands, we're only going to plug in 32 into our x. So we get y hat is 72.498 minus 3.684 times 32, and we get negative 45.4 degrees Fahrenheit. All right, and that's it. So if you have any questions, like always, let me know. Otherwise, you have a great day.